I'm going to talk to you this afternoon about how we developed a project here in Jamaica which we believe could do a great deal to solve some of the world's most pressing environmental problems. I need to give you a little background first. By 2050, there will be somewhere between 9 and 10 billion people living in this world, which is about 30 or 40% more than there are today. By the time we get to 2050, about 3/4 of humanity will be living in cities. That's up from just over half today. Now, the combination of rising population plus people migrating into cities means that we're going to have to build 3 or 4 new cities every year between now and 2050, and every one of those cities will have to be the size that Mexico City is today, with over 22 million inhabitants. By 2050, we believe the population will also be significantly richer than it is today. And the combination of rising population and increasing per capita income means that we're going to be consuming significantly more energy, water, food, and resources than we do now. In fact, we're going to need about 30% more water, about 50% more energy, about 70% more food, and approximately 100% more materials than we're consuming now. That means instead of consuming today's level of 80 gigatons of materials a year, we're going to need something like 160 gigatons. And half of that will be sand, cement, and gravel, which we're going to need to build all of these new cities. The question now, the big question is, how are we going to survive this transition to this new future? Because before we're even halfway there, before we get to 2030, something like half of humanity is going to be living in water-stressed areas. And at present, we are on a path to achieve something like a 4% rise in world surface temperature before we get to the end of the century. What that means is that before we get to 2050, parts of the planet's surface will be becoming uninhabitable. Parts of the Middle East may have to be abandoned as being too hot. Parts of Bangladesh will be underwater, and many of the world's major cities will be prone to flooding. What this means is that we face 2 very different possible futures. If we continue on the current path, we may be looking at an accelerating process of global heating, eventually moving beyond the point of remedial action, and with catastrophic consequences for much of humanity. The alternative is that we make a decision to start building much more energy and resource efficient cities, consisting largely of net zero buildings, using autonomous transport, and economic systems that run predominantly on renewable energy. Now, the increased demand for energy and materials is going to make it impossible to resolve the problems of climate change and meet people's needs without enormous improvements in energy efficiency and productivity. So how can we do this? Well, is there no way that we can do this without making our buildings far more efficient, both in construction and in use. And the reason for this is that building construction and building use combined are responsible for over 1/3 of global energy demand and nearly 40% of the world's CO2 emissions. So if we can find a way to make our buildings more efficient, we can largely solve the problem of climate change. And if we can make them more efficient, we can also make them much cheaper to operate, which means that people will have increased levels of disposable income, which means that we'll then see increased growth in other sectors of the economy. This is one of the very few things that we can do to actually fix our environmental problems that also makes us richer. Now, where we really need to see improvements is in countries like this one, in the tropical and subtropical regions of the world, mainly because that's where the new cities will be, but it is much more technically difficult to keep the interior of a building cool and dry in a warm and humid climate than it is to keep the interior warm in a cold climate. So we set out to solve this problem. We built a net zero energy building in Jamaica. It was the first in Jamaica, the first in the Caribbean region, and one of the first in the world in a subtropical country. A net zero building is a building that generates as much power as it consumes. In fact, some net zero buildings generate more power than they consume, so they're then able to export this to other people. If we could make all buildings like this, we could actually start to shut down some of the world's power stations. And we wanted to find a way that countries like Jamaica could simultaneously improve their energy efficiency, increase levels of disposable income, reduce their dependency on imported fossil fuels, minimize the risk of exposure to energy price volatility in future, and reduce the national contribution to climate change. One of the things that we discovered is some of the most effective ways that you can make a building very much more energy efficient actually cost little or nothing. And let me tell you the top 4. The first was simply to orient the building to the sun rather than to the road. And by doing that, we were able to greatly reduce the amount of unwanted heat gain, while at the same time improving the efficiency of the solar panels on the roof that supply the building with most of its energy. The second was to put the living spaces in the building into the interior and the service areas to the outside. And this did a great deal to reduce the unwanted heat gain in the areas that people use. Now, these actually are zero-cost changes. It's just changes to the layout. The third was to maximize the use of natural light for illumination, which just meant putting the windows in the right place. And the fourth was to use natural ventilation, which mainly involved making the ceiling higher. Now, none of those changes cost very much. Some of them cost zero, and yet they did a great deal to stop the wastage of energy from the building. But we know that this is not just an engineering problem. We do now know how to make buildings which are very, very much more energy efficient. The other issues which we realized we would have to address in Jamaica was, firstly, building regulations. Now, government regulations specify minimum building standards, and very few government regulations are aimed at making a building more energy efficient. In fact, some existing government regulations in Jamaica are very unhelpful because they lock in inefficient standards. So the government regulations, we realized, also have to be reformed and modernized. It's also about education. Architects and building contractors in this country mostly don't know how to design and build net zero buildings, so we realized we have a great deal to do in terms of working with the professions to ensure that everybody knows that this is what we can now achieve. The third is it's also about market demand. People must know that there is now a better alternative if they're going to preferentially purchase buildings that cost them little or nothing to run. And finally, it's also about the fiscal system. We found that the government here and other governments elsewhere, place a high rate of tax on imports of the necessary key technologies, which makes efficiency appear less economically attractive. So all of these problems have to be fixed before we can expect to see progress. We spoke to the government of Jamaica about these issues, and we believe we persuaded them. The relevant minister did make a commitment to make every new building in Jamaica net zero by 2050. Now, personally, I don't believe we can afford to wait till 2050, so I hope that we can now persuade the government to adopt a more ambitious timetable. So, let me now show you Jamaica's first net zero energy building, the first in the Caribbean and one of the very first in the world in tropical and subtropical regions. This is the net zero building which we built on the University of the West Indies Mona campus in Jamaica. The solar panels on the roof generate enough power for the building, and by orienting the building with respect to the sun rather than the road, we did a great deal to improve the efficiency of the panels while minimizing unwanted heat gain. We also raised the elevation at the front of the building, and these simple zero-cost measures, including moving the living parts into the interior of the building, do a great deal to improve efficiency, as does using large windows to allow for maximum natural illumination, and using enough panels to generate enough power for the building, plus to net export to the rest of the university campus. This gives the building net zero running cost. So in Jamaica, we have been able to demonstrate a concept, one that offers a solution, not just to Jamaica and the rest of the Caribbean, but also to all of the tropical and subtropical countries of the world. This is how we can solve the world's environmental problems and do so in a way that makes social and economic sense for the whole of humanity. Thank you.